Okay, now that you've learned about angles, how to measure them, how to convert them, we've learned a little bit about the properties of a circle, arc length, area, linear velocity, angular velocity. Now we're ready to go on to what is called right triangle trigonometry. I know it sounds weird, we're transitioning from circles over to triangles, but the big thing we want to do here is be able to measure an angle on a triangle. So it's still the same thing. You're going to go from this side, rotate up. That is going to be the angle that you measure. Okay? So a little bit of sign convention that we're going to use throughout. We're going to label the vertices, the corners of a triangle, with capital letters A, B, C. Okay? And then the side opposite of this vertex. So little a is that side length. And here I'll try and use a different color so we can really see the difference. Okay. Lowercase is a side length. Vertex B, side opposite B. Vertex C, side opposite C. Okay. So I will use this notation for the measure of angle A. So we're talking about this angle right here. Now, one of the keys to right triangle trigonometry is the fact that we need to use properties of similar triangles. Okay? So similar triangles, they have same shape but different size. And so what we mean by saying the same shape, if this angle here has the same measurement as that angle, and sometimes we'll use 2 bars to say those two angles have the same measurement, and 3 bars to say those two angles have the same measurement. Okay? And we'll just pick P, Q, and R. Okay? So we have 2 triangles. They have the same shape but different size. We say the triangles are similar. Now, one of the beautiful properties of similar triangles is that their sides are proportional. Okay? What that really is saying that if I take the ratio of 2 sides here, it's going to be the same exact proportion as the other triangle. So what this says is my ratio of A over B, it must be the corresponding sides. That's going to be the same as P over Q. Okay. You can take any 2 sides. B over C, that corresponds to Q over R. If I want to take the ratio of C divided by A, that's going to be the same as R over P. Okay. So we're going to use this property when we come over here to look at right triangles. Now, let's go ahead and draw our right triangle. I'll call this A, this B, this C, with that being a right angle. Okay. So, again, I find my angle, the side opposite is little a. Find my angle, side opposite. Find my angle, side opposite is C. Okay. Now, the beautiful thing about a right triangle is if I have that angle there, as long as it's a right angle, I can now look at any similar triangle. Okay. So I could throw this triangle right in here. The property of that height to this side is going to be proportional to the other sides, and away we go. Now, what we do is you need to really concentrate on the next picture. This is really the key. Okay. So let me draw the same right triangle again. And everything that I'm going to write down now is in respect to angle A. Okay. So I identify an angle, I find my right angle. When we have this, the side opposite of the angle A will be right there. The side adjacent is right there. And the long side of a right triangle is called the hypotenuse. So I've abbreviated it side opposite angle A, side adjacent to angle A, and the hypotenuse. Now this allows us to define our trig functions. Okay? And what we're going to do is we're going to put an angle in to this funny function. Okay? And all we're trying to do is get up some sense of proportion that we can look at any angle A on a right triangle, and they're going to be the same proportion no matter what. And we just define the sine of this angle to be opposite over hypotenuse. Okay? The cosine of this angle is defined to be adjacent over hypotenuse. And the tangent of this angle is defined to be opposite over adjacent. Okay? Now there are many different little sayings and ways to remember this, but the big thing is sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So one of the ways people remember right triangle trigonometry is SOHCAHTOA. S-O-H, SOHCAHTOA. Sine is opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent is opposite over adjacent. Now, the big thing that we have to realize is that if we have a right triangle, and we'll pick a simple right triangle, one of the things we're going to have to talk about in the next little slide or session is when do we have a right triangle and when do we not. Okay? But we want to evaluate the sine of this angle. So if I want the sine of angle A, sine is opposite over hypotenuse. Okay? Cosine of this angle is the side adjacent divided by the hypotenuse. And lastly, the tangent of this angle is opposite over adjacent. Okay? Now I said this is fine, but we really have to identify what we're talking about, because if we change the angle, the side opposite to B is 4, the side adjacent to B is 3. So you must be very careful when you're evaluating these trig functions that you identify the angle, the side opposite, hypotenuse, angle, side adjacent. Okay. Go and practice, draw these right triangles for every single one of these, and you'll get them right every time.